Restart. Yeah. What about this is visible now, right?
Yes, sir.
Have you tried this question which I gave yesterday?
No, sir. Yesterday was out the entire day, so I couldn't. But I'll do it today and I'll send you the picture.
It's okay. You can do it now. It will not take much time.
I don't have a notebook with me right now. Like, I'm still outside.
Oh,
So can we do the theoretical part today? Like, I can't do the questions. I don't have any notebook or anything with me.
okay. Then let's study about what types of magnetism. Okay. Mm, One second, please. Let me adjust something here. Okay. Yeah. So, like electron, let's study about electron and magnetism, diamagnetism. Yeah, diamagnetism. No, what happened in diamagnetism? See, like they have some paired electrons. So, what happens when there is a paired electron? This magnetic moment they cancel each other. So, due to that, there is no overall magnetic moment, or we can say net magnetic moment, especially for diamagnetism. They have paired electron. If they have paired electron, then magnetic moment cancel each other. So no net magnetic moment. What else we can say? F equals to QBV. Q is your charge, B is your magnetic, and V is your velocity. Now, when there is an external electric field, each electron, let's take here F equals to EBV. Each electron experience outward force or inward force. Are you able to hear what I'm saying? Is it audible?
Yes, sir.
Okay. So when a diamagnetic substance is placed in some external electric field, so either they will experience some inward force or outward force because of this angular velocity. Angular velocity. Either here, either inward or outward. Outward force. Due to that, there is an angular velocity. due to that angular velocity, then what we can say, what else changing? Current also, because I equals to q by t. Due to the force is depending on all this quantities, so obviously angular velocity will change. Then current also,
Yeah.
and magnetic moment. So what is happening here now? All this inward force, outward force, that due to that current is also changing, angular velocity is also changing, and magnetic moment is also changing. What changing of what? Of one electron. So in short, first electron increases, other decreases. So overall they got balanced. Overall they got balanced. So that is the reason there is no net magnetic moment.
So this is like similar to like wrongly connected capacitors.
Yeah. But it doesn't mean that it is having zero magnetic moment. Okay. It's not like one magnetic moment here. So here we can say this result in non-zero magnetic moment in the substance in direction opposite to P. So let's write properties of it. Now, properties means same thing we have to consider again. Now, properties means what we can say, diamagnetic substance, if it is placed in external electric field, it get little magnetism or feebly magnetism, where opposite. So let's write property here. The substance placed in external magnetic field acquire feeble magnetism, which is opposite to direction of field. See here only it's written. Direction of magnetizing field. These are diamagnetic substance. So example we can say bismuth symbol, zinc, sodium, copper, Actually, copper is dia as well as para both. Copper comes in both. Silver Ag, gold Au, salt NaCl, water, mercury Ag, what else, etc. Hydrogen in H2O, etc. Okay, so now let's draw and check for the magnetism, how it will be visible. If it is north and this is south, that's it. So obviously it will get north and south will get attracted like this. But for diamagnetic substance, what will happen? Like see, when a bar of diamagnetic substance, they are freely suspended. Yeah, north and south pole means two poles. So this axis, if you observe it properly, okay. This axis, let me change the color. This axis become perpendicular. Can you see my red color? My red color is visible.
Yes, sir.
So this is your north and south magnet. South. This becomes perpendicular. So in this, let's write in short. It will write here when this magnetic substance or bar of diamond substance really suspended between two poles. Then what will happen? Axis of bar becomes perpendicular to magnetic field. Now same thing, we can write some more about it. Same way. So same way, if it is placed inside the magnetic field, not writing again, it is placed in inside magnetic field. field line become more dense. So in short, what we are concluding here, they have strong repulsive force. They have a strong repulsive force, but still it is a magnetic substance. It's a diamagnetic substance. So if it diamagnetic substance means what? It get feebly magnetized in opposite direction. Magnetized in the opposite direction. Then let's go for graph. Graph is important here. H. This is I. So for this we can write. So as it is getting feebly magnetized in the opposite direction, so I is what? Intensity. Remember? Intensity of magnetism. See, till now, whatever we wrote about this properties and all, that's not so much important. But graphs are most important. From this, definitely graphs are asked. Graph and temperature difference, temperature variation. Intensity is very small, negative. You can see I'm just writing from the graph. And proportional to H. Next, let's write about temperature. Are listening, right? Anti? Are you there? Can you hear me? Since magnetic susceptibility is I by H. And is small and negative because I is small and opposite in direction to H. So it does not depend on, or we can say independent. Temperature. Can you hear me?
Yes, sir.
Are you listening?
Yes, I'm listening.
Okay.
So can I send these notes, like in the app?
Yeah. Yeah. Sure. In this one, a relative permeability is less than unity. Less than unity, why? Because mu r equals to 1 plus xi, and xi is negative. So obviously it will be less number, less than 1. Something between. See, even all negative values and less than 1, all the values, those are permeability. Sorry, diamagnetic substance. Now, something greater than 1, those are paramagnetic. And very, very high value, like 500, 700, those are ferromagnetic substance, which we will see one example one by one. Why it's getting off? Is my screen visible?
Yeah, sir.
Okay. Then let's go for para. Now, paramagnetic substance, they have permanent. I'll just like point like word wise. Permanent magnetic moment. Okay, they have permanent magnetic moment. And movement, what whenever movement arise, it will be from both motion, like electron, as well as whenever we are spinning something. So movement, can write due to orbital motion of electron and spinning of electron in axis. So as this in paramagnetic substance, they are not completely filled. Inner shell is not completely filled. So there will be some net moment. Since like they are having more spinning moment, so they will have some permanent type, like little, not so much, but yeah, there will be some permanent type, the magnetic moment, as we have written first point. So inner shell are not completely filled. That moment is there. So therefore that moment is there. Because of spinning moment of electron. Spin of electron in same direction. So this will behave as a bar magnet. So let's write here. Behave as a tiny bar magnet. Now let's talk about the actual part, what we have discussed here like this. So when we are placing an external magnetic field, this atomic magnet, means what we said here, tiny magnet, atomic magnet align the direction of magnetic field, and they are opposite to them. So they get aligned. So let's write about alignment. So placed in external magnetic field, atomic magnets align in direction of field. Thermal. Okay, no need to write about it. And opposite direction. The properties will write. Now for properties. Now some simple property, first thing, like some substances are placed in magnetic field. They get feebly magnetism, which is in the direction that was out, opposite direction. Here, this is in the direction. So substance placed in magnetic field. Feeble magnetism. In direction of magnetic field. are known as paramagnetic substance. Example: aluminum, platinum, manganese, copper. What is this compound? Know the name?
Yes, sir.
You know the name?
No, sir. I was thinking about it.
Copper chloride.
Okay, wait, it's chloride or Cl2.
Copper
Yes, sir.
chloride. It is oxygen.
Yeah, I just didn't understand what you read. What I have written.
Mhm. Then all solution of salts of iron, etc. Whatever. So these are what examples of paramagnetic substance. Okay. Then all this temperature and ferromagnetic substance. We'll see it next class. To get ready for it. Office. ठीक है?
Yes, sir.
Can you hear me? Okay, fine. Okay, dear. Bye bye.
Bye, sir. Thank you.